This is lab 6. Dial caliper. As we go along, I tend to call this the vernier caliper. Difference is the vernier caliper does not have the dial on it, which makes it a little bit easier to read. Vernier has no dial at all. We will be measuring the same parts we've been measuring before, which is the push rod, valve stems, and crankshaft journals, mains, and rod journals. Already done on the vernier caliper. This is my favorite tool. Most of the time I don't do precision measuring. Usually measuring how long is that bolt, how long a bolt do I need to order from Amazon, or how long am I looking for when I go to a hardware store to try to find one. The beauty of this tool is it will measure outside dimensions here, inside dimensions here, and depth here. Let's see, there, depth right here. More better. Depth here. Okay. This tool has a scale, and I'm all tunneled in on this one. The light, of course, doesn't work well with this. Overhead lights are okay. Tried everything. If this works, we'll just switch over here. This has a scale very similar to the outside micrometers, except it's got it all in one. This specific vernier caliper does 0 to 6 inches. That's the standard. You can buy them. They have them longer. And for the tutorial, this number 1 here, that represents 1 inch. And if we had gotten to 2, the way I have it set here, would be at 2 inches. Each one of these lines after the big number is 100 thousandths, or 0.100. I think I did 2 zeros there. 0.100. That's it. So if we stop on just a little bit past the line, like here we're at 7, and the rest of the thousandths of an inch from here we're at 1 inch, 700 thousandths, plus whatever's on the dial right here, which is 49. 1.749 would be the reading from this vernier caliper measurement for the outside dimension, the inside dimension, and the depth measurement, all but that. This is to lock it down when you make your measurement. Boy, this is kind of tricky getting a very good there. When you take it off, sometimes it wants to move. This knob here is for locking it down. This one is to, this one on the bottom is to lock the scale, which turns. You want to start with 0. You want to set it on 0. Okay, let's get started. So the question is that I just had for myself was, when do you set it on 0? Well, you don't set it on 0 when it's all the way up. You set this spin dial on 0 when you have it totally closed. Right there. Otherwise your measurements are off. We're just measuring for practice on readings anyway, so at this point I would lock this down. And now I've calibrated my vernier caliper to 0, so that anytime I open it,
my dial will be correct. And check that. Alright, we're calibrated.
This is the push rod measurement. You need to, in order to maintain some accuracy, you need to tighten down that little knob at the top of the dial, the top of the screen here. Because when you take it off of the part that you're measuring, you'll get an error. It'll move just a little bit, usually wider, and you get an inaccurate measurement. This is our exhaust valve stem measurement. Best to use the little wheel at the bottom to scroll the caliper together and then lock it down with the knob up above. And this is our measurement reading. This is a measurement for the exhaust valve total length, where you use the end of the dial caliper, the little rod that extends out towards the end, and it goes all the way down, and you raise it up until you're at the top, in this case up to the top of the valve stem itself. Pay attention to how I'm doing that. It's actually incorrect. I'm having to lean it into the top of the valve stem in order to know where to stop. Otherwise, I'm making a rough visual guesstimate of where the top is, unless I have some kind of straight edge laying across the top of the valve stem. And so I've lost some accuracy there because of geometry. The hypotenuse of a right triangle causes me to be in error, so I'm going to ask you to explain that to me. This is the intake valve stem measurement. I'm going to zoom in here on the valve stem. There's a shiny area where you measure the valve stem for wear. Many students ask me about that. Where do you measure this? So there's a lot of length, but not all of it is a wear area. Most of the valve is down in the combustion chamber. So this is our measurement. This is intake valve length. When the measurement comes up, pay strict attention to the details. There's a line is showing and a number of parts are showing, but it hasn't really made it past the zero, so you can be off by 100 thousandths. Next is piston diameter. It's challenging with this tool to get an accurate measurement because it's difficult to find the true circumference of the piston. You end up on a short side, or and the true circumference is, of course, the maximum. You can measure short and a short diameter and think it's all right, but it's not. And also, if you try to go through where the grooves are, and then once you fall into the grooves, but it can be done with enough practice. You can get pretty accurate with it. As I mentioned early on, ideally I like to use it for straight flat things like the length of a bolt or something like that. Or inside dimensions, it's really good on that. It's the diameter of a hole. Or depth. It's pretty good on depth, except it doesn't have a broad enough base to be a really good depth gauge. Next is crankshaft measurements. We're going to start with the main bearings first. We're going to, of course, start with any of them. We're going to start with number one main bearing. Picture's a little bit awkward. Remember, number one is in the front, the long end of the crankshaft. This is number 2 main bearing journal. This is main bearing journal number 3. This is number 4 main bearing journal. This is number 5 main bearing journal. Most all automotive engines that I've seen have 5 main bearings, whether they be a six-cylinder inline, V8, V6, 4-cylinder inline. All that I've seen have 5 main bearings. Uncertain on the horizontal flat engines. Next we'll measure rod bearing journals. All the rod bearing journals are the ones that are offset from the center line. All the mains are on the same plane as I describe it. So all the ones that are offset. And we're going to start in the front. We'll start with number 1. This is rod journal number 2. This is rod journal number 3. This is rod journal number 4. Since this is a 4-cylinder engine, this is the last one. This completes slab number 6, dial caliper.